So good morning children. So last class we have discussed up to force on parallel current carrying conductor. Force on parallel current carrying conductor and electromagnetism. So what is the comparison between electricity and magnetism? So together it is called electromagnetism. So today we are going to start the new topic, electric motor. Before that, what is meant by electrical energy? So energy is nothing but what? The ability to do the work, that is called energy. So electrical energy, it is a one type of energy. So with the help of electrical energy, so one of the instrument is converted into mechanical energy. So that instrument is nothing but what electric motor. An electric motor is a device which converts electrical energy into mechanical energy. So electrical energy is converted into mechanical energy. How? How the electrical energy is converted into mechanical energy? So we kept what if you are seeing the electric motor inside with already they kept what? One magnet, permanent magnet. So around the magnet, coils. Around the magnet, coils are rotated. So if you are passing the electricity, the magnetic field is produced. Because of the magnetic field, one type of force is created. That force is acting on the conductor. The force is acting on the conductor. Because of the force, the electric motor start to moving. Because of the force, the electric motor start to moving. So in this way, which one is working? Electric motor is working. So we have attached with what type of magnet? Permanent. So next we will see the working of the electric motor. Working of electric motor. So we have to take the two type of magnet. So one is acting as a north pole, another one is acting as a south pole. One is acting as a north, here south, here south, here north. So middle we may keep what coil. So here rod. Here rod. So we are passing the electric current in this directions. A, B, C, D. So here we have attached with the bush. We have attached with the bush. Carbon brush. Carbon brush. This is called magnet. So in this way, this is the path of current way. So here, split ring of commutator. This is the small diagram of working of electric motor. So two permanent magnet. So inside we have to kept coil with the rod. So we are passing the electric current in this directions. A, B, C, D. So in this way we may pass the electric current. conductor, okay, the passing of the electric current in AB in which direction? One of the direction, okay, in CD in opposite directions, okay, opposite directions, okay. So in this way we may pass the electric current, okay. The motor start to rotate in clockwise directions, okay. Clockwise means in this directions, in this directions, okay. Can you understand, ma? So if you are passing the electric current, half of the portion is rotating one direction, half of the portion is rotating another one direction. That means what, ma? Okay, in this portion electric current is passing AB, okay. In this portion electric current is passing CD, okay. The next, ma, the down, okay, attached with the carbon brush, okay, that is called X and Y, okay. The next one, split commutator, okay, split commutator. So what is the uses of split commutator? Okay, to change the direction of the current, okay, to change the direction of the current. So if we want to change the directions, okay, instead of in these directions we want to change in these directions, okay. So we have to keep one of the small instrument, okay. That instrument is nothing but what, ma? Split ring commutator, okay. To change the direction of the instrument, okay, a small device called split ring commutator, split ring commutator, okay. So in this way, which one is working, ma? Working of electric motor, okay, because of the magnetic field, because of the magnetic field, okay. So if you are increasing the strength of the magnetic field, so okay, automatically magnetic flux also has induced, okay. So automatically if you are increasing the magnetic flux, okay, so it will start to rotate very fast, okay. Next one, the speed of the rotation, okay, the speed of the rotation of a coil, okay, can be depends upon, okay, can be depends upon the following factors, okay. Rotation of the coil, so based on the following factors. So what is the factors? Okay, first one, the speed of rotation of coil can be increased by speed of rotation of coil increased by, okay, the following things, okay. First one, increase the strength of the current in the coil, okay. Strength, yes, strength of the current in the coil, current in the coil, okay. First point, so we have to increase the rotation of the coil, okay. So first what we want to do, speed of the current, okay, or nothing but what, ma? Strength of the current, okay. Voltage we have to increase, okay, strength of the current in the coil. Second one, increase the number of turns in the coil, okay. TUR, turns in the coil, we have to increase the number of turns in the coil, okay. Next we have to increase the area of the coil, area of the coil, okay. Last one, okay, we have to increase the strength of the magnetic field, strength of the magnetic field, strength of the magnetic field, okay. So we may increase these four, okay. Automatically what will happen, okay, automatically the speed of the rotation of the coil also increase, okay. First one, strength of the current in the coil. Second one, turns in the coil. Third one, area of the coil. Fourth one, strength of the magnetic field, okay. So next one, electromagnetic induction, electromagnetic induction. So what is mean by electromagnetic induction, okay. Electromagnetic induction. So induction means what, ma? Inducing, okay. Induction means what, ma? Inducing, okay. So when it was shown by the Wasser, okay, by the magnetic field is produced around the current carrying conductor, okay. The reverse effect also attempted. Okay, the reverse effect also attempted. Okay, current carrying conductor. Okay, if you are passing the electric current through the current carrying conductor, so what type of field is produced? Okay, magnetic field is produced. Okay, the same way opposite effect also is attempted. Okay, that is called electromagnetic induction. That is called electromagnetic induction. Okay, in the year of 1831, in the year of 1831, okay, Michael Faraday explained the possibility of, okay, Michael Faraday, okay, Faraday explained the possibility of producing an EMF across the conductor when the magnetic flux linked. Okay, so magnetic flux is nothing but what, ma? Particular area, how many magnetic lines are passing. Okay, that is called magnetic flux. Okay, so if we are mingled with magnetic flux to the conductor, okay, one type of force has created. Okay, that is called EMF. Okay, EMF is nothing but what, ma? Electromotive force. Okay, so he has demonstrated this electromotive force with the help of three experiments. What are they? Okay, first experiment. Okay, electromagnetic induction in a current carrying coil. Okay, electromagnetic induction in a current carrying coil. Okay, so if you are taking the coil, we may pass the electric current. Okay, so what type of field is produced? Magnetic field is produced. Okay, magnetic field, magnetic flux. Okay, magnetic field and magnetic flux is produced. Okay, so automatically, so we may attach the galvanometer. We may switch on and off. Okay, we may get the deflection. Okay, so with the help of this one, we will find out what, ma? Opposite charges also. Okay, second one. Okay, electromagnetic induction by moving the magnet. Okay, by moving the magnet. Okay, so in this experiment, current is generated by movement of the magnet. Movement of the magnet. Okay, in and out of the coil. Okay, so if you are taking the coil, okay, the middle of the coil we may insert the magnet. Okay, moving up and down. Okay, so what is produced, ma? Current is generated or voltage is generated. Okay, to the greater the number of turns, okay, we may increase the number of turns of the coil. Okay, so we may get the high voltage. Okay, so third one, electromagnetic induction by moving the coil. Okay, so we may, okay, magnet we have to keep in the permanent. Okay, so magnet we have to keep in what position, ma? Permanent positions. Okay, we have to move the coil up and down. So automatically voltage has produced. Okay, so because of this, okay, so which one is produced? Electromotive force. Okay, that is called electromatic induction. Okay, Okay, so what is meant by electromatic induction? Okay, the phenomena of producing electromagnetic induction. So what is the definition for electromagnetic induction? Okay, the phenomena of producing an induced EMF. Okay, electromagnetic induction. So what is the definition for electromagnetic induction? The phenomena of producing EMF. Okay, EMF is nothing but what, ma? Electromotive force. Okay, due to change in the magnetic lines, of forces associated with the conductor. To change the magnetic lines of force. lines of force, okay, associated with what ma? Conductor, okay, associated with a conductors, okay, that is called electromagnetic induction, okay. EMF is nothing but what ma? Electromotive force, okay. So in this way we have to create what ma? Electromagnetic induction and then electromotive force, okay. Next one, Fleming right hand rule. Fleming right hand rule, okay. So what is mean by Fleming right hand rule? Okay, the Fleming right hand rule is otherwise known as generator rule. Generator, okay, GENERATOR, generator rule, okay. Fleming right hand rule is otherwise known as generator rule, okay. We may take the right hand, okay, we may keep the thumb, middle finger and forefinger perpendicular to each other, okay. The thumb finger showing motion of force, okay, motion of force, okay, motion of a force, okay. Second one, okay, the middle finger, okay, the middle finger shows induced current, okay, induced current, okay. The forefinger shows that magnetic field, magnetic field means what is the symbol ma? Capital letter B, okay. So what is the definition for which one ma? Fleming right hand rule, okay. So we have to take the right hand, okay, thumb, middle finger and forefinger we have to keep perpendicular to each other, if the forefinger indicates the direction of the magnetic field and the thumb indicates the direction of the motion of the conductor, then the middle finger will indicate the direction of the induced current, okay. So this rule is known as Fleming right hand rule, otherwise known as generator rule, okay. Generator rule, okay. Book itself one diagram is given, okay. They have explained with the help of right hand, okay. You have to see the textbook, okay. So that's all, today class is over, okay. The remaining part we will see in the next class, okay. So one more class we will send the video, that's all, portion is over, okay. So today homework, okay, continuous question number should be given, okay. Question number 64, okay. Define electromagnetic induction, okay. Question number 65, okay. State Fleming, okay, state Fleming right hand, state Fleming's right hand rule, okay. Question number 66, explain, okay. Question number 66, okay. Explain the construction of, principle, construction and working of an electric motor, okay. So that's all today. Totally how many questions ma? 3 questions, okay. 64, 65, 66, okay. So remaining part we will see in the next class, okay. Thank you.